We're starting out today. Yesterday we talked about finding points of intersection using the calculator, and we talked about finding zeros using the calculator. Today we're going to apply those to some really fun problems. A couple of which are maximizing profit. Okay, there's one about a farmer and his fence and maximizing volume, and we're on 8B. Okay, so this is what we did yesterday, and now we're on 8B. Everybody good? So it says a box with a square base and no top is to be made from a piece of cardboard by cutting 6-inch squares out of each corner and folding up the sides. So here's my model. Okay, so they have a piece of, it says a square piece of cardboard. I'm a loser already. Okay, so it says they had a square piece of cardboard. So my model needs some adaptation. I don't know. I'm just guessing. They had a square, okay, so it looked like this, right? A square. And then they cut squares out of the corners. Yes, okay. So it was a square, they cut squares out of the corners, and then they're folding up the sides of the box. So it's going to look like this. Is this making sense to anybody? It's going to make a little box. Okay. Do these all the time when you get to calculus. Okay. So they cut corners out here. Oh my goodness, that doesn't look like a square at all. And now they folded it up and made it three-dimensional into a box. All right. So what do we know? This 6. What is this 6? Yes, this was 6 inches by 6 inches. 6-inch squares out of each corner. Huh. So it must have been pretty darn big to begin with, right? So this dimension is what we don't know. How big of a piece of cardboard is needed? So this was x, and because it's a square, we don't really need two variables. This side would also be how long? X. Now, when we start taking the 6 inches off here and here, we need an expression for this piece that went from here to here. X minus 12. Anybody agree, disagree? Why is it not x minus 6? Yeah, because you went in 6 from this way and 6 from this way. So x minus 12. Good call. Now, when we start folding the box up, okay, is this one different over here? No, it was still x minus 12 over here because of it being a square to start with. Okay, where are those dimensions on our box? Look up here if you need to. So this was x. We took off 6 this way, 6 this way. This piece is x minus 6. When I fold the box up, that's like the length or the width of the box, right? And we said because it was square, this one is the same. So we have an x minus 12 here and an x minus 12 here. But how tall is our box? 6 because of the squares that we cut off. Everybody seeing that? Okay, so the box needs to hold 1,000 cubic inches. That's what kind of a number, cubic inches? That area? It's volume. So what is the formula for volume of a box? Length, width, height. So the volume has to be 1,000 if the length, width, and height are what? from our expression right here. Can I start with the 6 even though it's really the height? Okay. And then the length and width are both x minus 12 and x minus 12. Might be faster to type it in our calculator as x minus 12 quantity squared. Now, how are we going to solve that if we want to use graphing? Actually, probably be faster to not use graphing, but we're going to use graphing. Into y1, we're going to put this equation, the right-hand side, and into y2, we're going to put what? We want to know when it hits 1,000. Can we do that? And then we'll have the intersection method, right? Because we've put in 2 separate equations. All right, so firing up my calculator, which I am not ready for. Oh, that's not even the one I want. Hotbar, try again. All right, you guys are all way ahead of me. Work on finding an appropriate window while I'm typing, okay? One of them was 1,000, and the other was 6 times x minus 12 squared. Guys, did I get it right? Okay, so my standard window is totally blank. One of the lines I graphed was clear up at what? 1,000. So I need my window to go up to 1,000. Which number is that? Not x max, because it's up and down, right? So it's y max. I'm going to put 1,500 just because I want to. Right now, ooh, I'm getting something. But it's crossing over here at negative. Do you think our x should be a negative number? Probably not. So I'm thinking I need to go further out to the right to see where it crosses again. What do I need to do to increase that then? X max? I don't know. I'm going to put 100. Is that far enough? Ooh, looky there. Okay, so my window I have is negative 10 to 100 and negative 10 to 1,500. You don't have to have that exactly, but can you at least see the intersection points? Whatever window you're using. Okay. Over here we look like we're having negative x. I don't think cutting a negative square out is going to work very well. So we need to find the positive place where they intersect. So second trace intersection. Enter, 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 because we only have 2 equations in. What's it coming out? 24.91. Anybody getting that? Okay. Let me drag this little screen onto the notes. So we solved it and we found that they intersected when x was 24.91. The question says, how big is the piece of cardboard needed? Remember, the cardboard was a square. So the original size of the cardboard should have been what? 24.91 by, yeah. What? X was the original piece. Yep. We could have done it differently. You're right. We could have put X and plus 6, but we didn't do that. We did, the X was the original piece. So the original piece should have been 24 by 0.91 by 24.91 inches. We good? Now, the next one is really hard to do with one variable. It's a little bit easier if we think about it as 2 and then get rid of one of the variables. We kind of used an extra variable here when we talked about volume equals length, width, height, but a lot of extra variables. So the issue here is everybody wants to assume these are little squares, okay, and they're not necessarily. Farmer wishes to enclose 3 pens with fencing as shown. Okay, these are all going to be parallel, the up and down pieces of fence, so they're all going to be the same size. So if we want to put an X here, all of these lengths of fence will be the same X up and down. All right? But we don't know this dimension. This is not 3x, like it would be really easy to assume, okay? We don't know how long this is. So I'm going to start out by just calling it y for a minute, and then in a minute we're going to have to eliminate the y because we don't know how to use 2 variables. But what can you tell me right now about either the area or the amount of fence? Okay. How do you find area? The area enclosed is really just a big rectangle, right? It has some little fences splitting it up, but it's really just a big rectangle. What is the area of the rectangle? Yep, the whole rectangle here is just x times y. Okay. He has 700 feet of fencing to work with. Well, what is he going to have to break that 700 up into? He's going to have to cut off how many pieces go in this way? 4 that are each x. And then on these sides, he's going to have 2 y's, right? To make the long sides. And that has to total the 700 feet he has. That's really the perimeter, except it also includes the dividers in the middle, yes? Okay. One of those we can solve, okay, and put it in as a substitution into the other. What are we trying to maximize? Anybody actually read the question? Maximize the area. So we want to find the maximum area. So I can't have 2 variables in the area. Can anybody figure out what we could do with this disaster? Yeah, let's get the y by itself. That sounds like a really good plan. So first we would subtract 4x over to the other side. So we'd have 2y equals 700 minus 4x. And then we would divide everything by 2, which actually simplifies down to that y length is okay, so if he has 700 feet of fence, cut it in half. He's got 350 left. And out of that 350, he's going to cover half of one of the y's and 2 of the x's. I'm sorry, guys. All right, we're going to substitute that in up here so that we have an expression for area. It says x equals 350, I'm sorry, area equals x times 350 minus 2x. Now, if I were to distribute that, I'd have 350x minus 2x squared. A minus 2x squared indicates that it's a parabola that opens down. So will it have a maximum value? Okay, that's what we're trying to do, is find the maximum. So we could distribute it and use algebra. We could use our negative b over 2a. But we're going to play around with the calculator. I'm going to clear all this stuff out, and I'm going to put in that equation. X times 350 minus 2x Now, I don't really know what x is, except it's a length of fence. So I don't think it should be negative. Does that make sense, guys? And I don't know. I kind of doubt it's 100, but we could leave it to 100. But the y is actually, when we have graphed this expression, the y is the area that it's enclosing. So I'm thinking the area it's enclosing might be pretty big. Might even be more than 1,500. I'm just going to hit graph and see what happens. Whew. Yep. Anybody else getting something like that? Okay, so what do I need more of? And probably x, right? All right, I'm going to do 0 to 500. What do you want to try for x? 5,000 or something? Okay. What's wrong with mine? Still need more y. Now, this is the one time that it would be okay to use zoom fit, because if you find an appropriate x, the zoom fit will find the appropriate y. Maybe not for the word problem, but it'll help you find the appropriate y. I know x has to be about 0 to maybe 50, guys, right? Or 200 or something here. Because I had it going out to 500 there. 0 to 200 is a good x. Now, if you're not sure about finding the top, you can keep guessing, but now would be one of the few times that I would ever recommend you could try a zoom fit. Because it will find the top. Now, do we really need this negative business down here? No, but it did find the top for me. Okay. I want to find the maximum, which is choice 4. Now, it's somewhere between. You have to be clearly to the left of the maximum, and then scroll over clearly to the right of the maximum. What'd you get? Okay, 87.5 is the x value. What is the y value telling us? Do you remember what I said the y was? If we look back, sorry, trying to, x times 350 minus 2x, right here. Represents what, guys? What's the y right here? What word? Area. So it will enclose the area of, what does that say? 15,312.5 square feet. Okay, that's the y value, is the area. But it asked us for the x. Okay, what dimensions will maximize the area? So when we graphed it, put this on here. The maximum area, which if you wanted to say was 15,312.5 square feet, is enclosed when the dimensions are what? Okay, I'm coming. What's the x, guys? 87.5 feet by, we need to find y. Anybody figure out how we could find y? Yeah, right down here. Can you put that 87.5 back in there and tell me what you get? 350 minus 2 times 87.5. So your window was different, but it still works, okay? Somebody tell me what you got after you typed it back in there. 350 minus 2 times 87.5. 43.5. Is that what someone else got? No? I totally can't hear, that's why. 350, whoa. 350 on the home screen minus 2 times 87.5 is 175. Yep. Is that what you got? Okay. It's kind of miserable. 2 variables to start with. I will tell you, this is more like the one that's on the quiz. It says a salesman finds that her sales average 40 cases per store when she visits 20 stores a week. Okay, so I sell M&Ms to Walgreens stores, okay? I go out and I go into the store and I schmooze with the manager. I take them a Starbucks and I say, how many do you want to buy this week? Okay, I average 40 cases a store if I go to 20 different stores over the course of the week. It says if she visits an additional store each week, her sales decrease by 1. So if I spend a little less time smoozing with the manager, okay, I'm there, I find time to go to one more store, but because I wasn't schmoozing as much, my sales drop a little bit. Is this making sense, guys? So at some point, it's probably good that I go to more stores, but there's going to be a magical point where it's not, right? So what's happening right now is if I go to 40 stores, how many cases do I average? Nope, that's not what it says, Hofbauer. Someone help me. If I go to 20 stores, I will average 40 cases, which would be a total of 800, right? 20 times 40. What happens if I go to an additional store? This goes up to 21, but this one drops, it says 1 case, which will go to 39. So what's 21 times 39? 819? No? Is that what you said? 819. Okay. Well, if I go to 22, this will drop down to 38. Anybody got that one? 22 times 38? 826, 836. 836? Okay, still going up. You could do this by hand, by guess and check, but that's not going to get you full points on the quiz because I need you to be able to write an algebraic expression. What did this start at? 20 cases. Okay? X is going to, this one is going up, right? So X is going to represent how many stores per week should she visit? Well, I'm going to say X is the number of additional stores. So is this going up by 1s or 2s or what here? Just by 1, so up 1x. Now we're multiplying. What's happening on this one? Starting at 40, it's going down or subtracting by 1x. Now, if it had said every time she goes to another store, she sells 3 less cases, then it would be going down by 3x, okay? Now, if we multiply those together, we get the total sold. And that's what we're trying to maximize. So, if we FOILed that all together, would we have a parabola? Yeah, because we'd have a minus x squared, right? So parabola that's opening down. So let's type that bad boy in our graph. All right, it was 40 plus, and I already forgot, 20 plus x times 40 minus x. Okay. Anybody have any idea what kind of numbers we're looking at here? Think about this for a second. what's the maximum X could be in a real world situation? Look at that. Can you take away more than 40 from 40? No. So I'm thinking 40 is the max, right? So for our window, I'm going to do 0 to 40 for my X's. Now, how many cases did we sell originally? Remember what we wrote down in our little chart? 800, right? But it was going up. So I'm going to just put like 0 to 1,000 and see if it maxes out in that window somewhere. Does that seem okay? So thinking about your window is pretty important for these. All right. Oh, looking good. What are we trying to find again? Maximum. So if I go second, trace, maximum, I'm actually just going to type. It's somewhere between 0 and 40 if you want to do that, or you could put a smaller number in. You could cursor around. Now, mine has a small bit of calculator error. Did yours come up exactly 10,900? Mine says 10.0003. Okay. Anyway. 9.9999 something? Okay. It's calculator error. Is everybody in agreement that you have a roughly 10? Okay. So we should sell 10 what, though? Be careful. Oops. Nope. What was 10 representing? Nope. Be careful. Additional stores. There you go. So 10 was how many additional stores we should go to. At the maximum on our calculator, we got 10. What was that? 10,900, guys? Okay, so we should go to, or she should visit 10 additional stores, which makes it what? If you, go ahead. That's calculator error. Okay, mine got 10.0003. So it's okay to round to the nearest whole number. It's just finding, if we did this algebraically, Martin, if we FOILed that together and did negative b over 2a to find the maximum, it would occur at exactly 10. Okay. So when x is 10, but we have to plug that back in, it means she's going to go to how many stores? 30 stores. And that means she would actually sell 30 cases per store, right? 40 minus 10 would be 30 here. And it would make a total sales of 900. But this is what it wanted to know. How many stores should she visit? All right. One more of these. Can you try setting this one up on your own real quick? What time are we done? Oh. Well, I need to pass out the retake. So we have 120 bowls at $4 a bowl. For each 50-cent decrease, so this is going to go down to $3.50. 20 more bowls will be sold, so this will go up to $1.40. Okay, 4 times 120 is $4.80. 140 times $3.50. Did anybody try that yet? 7 times 70. $4.90, I think. Is that right? Okay. So what is this one going up by? This one's going up by, from 120, it's going up by 20s. So X is actually the number of price changes. It's not the actual price, okay? And this one started, just kidding, it's the number of additional bowls. It's the same thing, number of price changes. So this one started at 4, but it's going down by what? 50 cents every X. Okay, so then we'd need to graph it and find the max. Can you guys work on that while I pass this out? I'm just going to pause. All right, so I typed 120 plus 20x and 4 minus 0.5x. And I know that x is the number of changes, so it doesn't seem like it'd be very much. And y is the revenue, which started around 480. You think 10 changes is enough? You're right. You're right. So even 8 would work. And the max was over 500, maybe. Yeah. It's in there somewhere. This is really not a great window because it's hard to tell there's a max. If I did say that this was like 550, it's a little bit clearer that it is maximizing in here somewhere. And if I choose max somewhere between 0 and 8, it's at 1. So 490 is the max. Because if we had tried to go up again by 20, this would have gone down to $3 and it would have gone back to 480. Now, when we find the maximum, though, we've got to remember what price should be charged. Got to put the 1 back in here. So the max profit, or revenue in this case, I guess, is at $3.50 per bowl. All right, and the assignment, guys, is to finish up the second thing on the homework check. So I'm just adding 4 word problems from 9B today. So on the homework checklist, you should now have the first 2 things done. Took us 3 days to get there, but the first 2 assignments.